The notes in front of them? Yeah. Right. So, Alistair, do you recognise this stuff? You've done this already? Right. Okay. Actually, let me ask everyone. Just do edits. Right. Can I just ask you guys, without, you don't need to write this down because you've got this all as notes. If I said to you, 4 to 7, 10, 13, 16, so on. All right. If I ask you to write the general rule for that sequence, what would you do? Okay. So we would look at this and say it's +3, +3. Now that's what's that called, by the way? That's not the general rule, that's the this is called the common difference. You should have all this written, you don't need to rewrite it. Right, common difference, or it's called the term to term rule. Okay, so that's the term to term rule. All right, you might remember that this is the first line of difference. Yeah, remember the first line of difference, second line of difference. So if we know it's +3 every time, how do I work out a general rule for this? Not for this one. Okay, so we can say that UN equals 3n. Remember why it's 3n? Because it goes up by 3 every time. Now what? That's what we're trying to write. So if I remind you then, so n is the position in the sequence. So 1, 2, 3, 4, 5. So there are 5 terms. So 16 is the 5th term in the sequence. So n is the position in the sequence. So if I want to know U1, well, we do 3 times 1 and we get the answer 3. But I want 4. So what do I have to do? +1. So this, remember, is the adjustment that I need to do. So UN is 3n plus 1. And I can do a check then because U2 will be 3 times 2, but we have to plus the 1, which would be 6 plus 1 would be 7, and that is what I like. That's what I want. Do you remember what this kind of sequence is called? So we've got an arithmetic sequence. Another name for this is actually linear sequence. Okay, we call it a linear sequence. Yeah. And if I were to plot that on a graph, if I were to plot, for instance, I can go back if you are trying to make notes, don't worry about it, or I can just print that off. Right? If I draw a graph, and on this graph, this is the n and this is the un value, 1 will be at 4, 2 would be at 7, 3 would be at 10. Okay, so if I plot that, I would end up with a straight line. Yeah, so that's why it's called linear. All right, that was just a quick recap. And then we had a different type of sequence. What type of sequence did we have? Pardon? No, you're looking at today's notes. We're looking at previous stuff. We had arithmetic, which is going to be in today's stuff, but we had quadratic ones, yeah? So, for instance, if I gave you a quadratic sequence, well, actually, can I have a look at your book? That's the right one. No, have you got the other one? No, it's not. So if I gave you this one, so 5, 11, 19, 29. All right. What's the next term in that sequence? How'd you get there?
No, I mean what?
Because this is plus
6.
6, but this one's plus.
8.
This is plus.
10.
So we think the next one is going to be plus 12. So that would give me 41. Okay. Now, what do we notice about the first line of difference? It's not the same number this time. So this time, the first line of difference is not constant. So what did we do? But what did we do next?
You put the lines at the bottom, make the second line of difference.
Okay, we now do a second line of difference. So we did plus 6 is actually plus 2, plus 2, plus 2. So the second line of difference is constant. Now, what did that tell us? It's not linear. Second line of difference means it's quadratic. Yeah. If we ended up going to a third line of difference, which we haven't done and we don't need to, it would be a cubic, right? This would be a 3. Third line of difference. By the way, you've got all of this now. I don't know about Alistair, but you guys have got all of these notes. We don't need to write this out, right? Again, I can print this out, but it's just repetition of stuff you have done over. You should be like Eden. You have your old notes in front of you. You can recap on that. All right. What do we do at this stage, though? So what does plus 2 tell me? No. Close. Plus 2 means that we are going to have, do you remember we did plus 2, we divide that by 2 to get 1, so we have 1n squared. We know it's an n squared because its second line of difference is quadratic. And do you remember that table we made? If it was plus 2, it's 1n squared. If it's plus 4, it's 2n squared. If it's plus 6, it's 3n squared. If it's in between, plus 3, it's 1.5n squared. If it's plus 5, it's 2. So we took this number and we divided it by 2. So the plus 2 divided by 2 tells me how many n squared we have. Now, Sienna, we want to do a table, don't we? So we were going to do a table, okay? And we said, well, if n is 1, 2, 3, 4, and 5 for these, what would 1n squared be?
2.
1 squared is, 2 squared is, 3 squared is, 4 squared is, 5 squared is,
25.
okay? All right? But do you remember we said that's not what I want these ones? So we have 5, 11, 19, 29, 41 is what I want. Okay, so what did we do? We found the difference, yeah? So the difference is, so that's plus 4, this one's plus
6. No, 7, 7.
plus 7, this one's plus,
10.
this one's plus,
13.
this one's plus.
6.
So that's the adjustment, all right? Now, before, with a linear, our adjustment was just the plus 1 happened every time. Okay. Do you notice, by the way, these numbers compared to what we've just done? So, it's not going to be, this line is going to be n squared plus something. Yeah? Remember that? What's the something? Well, the something changes every time. But you will notice that the something is what kind of sequence itself? 7, 10 is a linear one, isn't it? The same linear that we did before. So that's plus 3. What is a rule for just this sequence? Plus 3 is going to be? Now forget this at the moment. How if I write a rule just for these numbers? So it goes up by 3, so it starts with, what's the rule for this? 3n. Remember?
119.
3n. 3 times 1 gives you, but I want 4, so it's 3n plus 1 again. 3 times 2 is 6, plus 1 makes. 3 times 3 is, plus 1 is. So this is what we have to add on, okay, to get to the 5 I want, yeah? So this number here is n squared plus 4. This number is n squared plus 7, yeah? Got it? Because this changes, we're looking for a rule for just these numbers. We found out it's 3n plus 1. So what does that lead me to? Well, it's going to be n squared plus 3n plus 1. Quadratic sequence. Do you remember we spent a long time doing this before the break? We've got all your notes. Maybe you want to share your answer and photocopy and stuff. I don't think I kept any spares. All right. Yes. Yeah. Yeah, it should be there. Yeah. All right. That's a recap. Now, if you're looking a little bit lost, so what have you got to do? Practice. You've got to review and practice. We can't give any more lessons on it. We need to move on. All right, you've got to review and practice. So it's not a complete change of pace, it's not a complete change of topic, but what we're going to do, look, is we're going to basically do the same things, but look at it in a slightly different way. And we have, like you've just seen, arithmetic sequences. All right. We've just looked at that. What's another name for arithmetic sequence? Linear. Now this time, we actually have a new word, geometric sequence. Any ideas what you think that is? Makes sense. It's not, it's still numbers that go up in a pattern. Do you think it's a quadratic? Another name for quadratic?
Yes.
would make sense, but it's not. Okay? So basically, we've had arithmetic or linear, and we've had quadratic from before. Now we're introducing a third option, which is called geometric. Alright? And what we're going to do is, you can add to these notes, by the way, on the paper that I've given you. So, an arithmetic sequence, if I had to sum it up, it would be a plus D. Okay? So we are, and you've seen this, adding the same every time. Why was a quadratic not arithmetic? It changes, yeah? It wasn't add 2, add 2, add 2. It was add 2, then add 3, then add 3. Alright? But an arithmetic or linear is adding the same every time. A geometric one is timesing by something every time. And we don't use a D, because D stands for difference, okay? D stands for difference. We have multiplied by R, which means we multiply by the same thing each time. And R stands for, any ideas? What? Ratio. I heard a couple of people say. Good. Ratio. Now that's because difference is another word for what mathematical operation? Subtraction. So if we're looking at how do I figure out what adds on? Well, what we do is we subtract, yeah? What's another word, what's the mathematical operation for ratio? Division. Makes sense, right? So if we're trying to figure out what we multiply by, you divide, don't you? So that's why we've got that. Now, quadratic was different because quadratic isn't add the same or multiply the same, it's add different every time. So geometric is going to be slightly different. So, what we're going to be doing is, it says here, understand the difference between a recursive formula and an explicit formula. We'll get there eventually. The one that we're going to focus on today is an explicit formula, all right? And we're going to use given formulas. So there's a clue. You're going to be given a formula to write an explicit formula for arithmetic and geometry. So, do you remember when we did the quadratic formula for solving the quadratic? We had a formula and it was given to us. Does anyone remember it off the top of their head? The quadratic formula. I'll give you a clue. It started with minus b. It's so close. Minus b, plus or minus, got that right. Square root, got that right. B squared, got that right. Minus 4ac. All of that divided by 2a. We don't need to memorise what we've given us in the assessment, but it's great that you got really close. But we had a formula and we had to put the numbers in and use it correctly. It's not as easy as it looked, right? Now the same thing here. We've been given, I've given you this in your notes, an arithmetic sequence with the first term A, give it a letter because it could be any number. Common difference, remember we've done that, is D. It has a recursive formula. Now we'll talk about that another lesson, but it has an explicit formula of this. So can I get you to write down that underneath in your notes? So we've got an arithmetic sequence, explicit, oh, not explicit, explicit formula, okay, is UN equals, do you remember the UN bit we talked about before? A plus n minus 1 times D. Now here is where we say that an explicit formula is the same thing as a general rule. So you've already been doing this. This is something you've already done. So you will be given this formula in e-assessment. If you can't remember the process that we did at the very beginning of this lesson, if you can remember how to use the formula and they give it to you, all good. And I'll tell you why I say that. Because let's use this formula to work out, do you remember it was 4, then 7, then 10, then 13, then same one, yeah? Remember what the rule was for that? We just did it. But it was 3n plus
1.
3n plus 1. So we know. Let's see our formula gives us the same answer. Okay. So based on what it says here, right? First term A. So in this case, A is what? 4. Okay. D is the common difference. So what's the common difference? 3. Okay. Why is it 3? Because it's
Plus 3.
plus 3 plus 3. So this is the D value and this is the U1, so therefore that's the A value. Alright? Now we've just got to put that into this formula and see if it gives us 3n plus 1. So let's have a look. UN equals, instead of A, I'm going to write 4. Yeah? Plus n minus 1 times what?
Times D.
Times 3. Yeah. D is 3. Okay. Now, just out of interest, when we have brackets in a number, do you remember what we do instead of writing it like this? Where does the number normally go? Well, normally you would see it with the number before the brackets, so 3 times n minus 1. Okay, I didn't want to confuse you, so this 3 is the D. I've just put the D in front when I've got the number, right? Is that okay with you?
Yeah.
Now, because there's two things, I either confuse you with writing it or I confuse you with what we have to do next, which is expanding the brackets. So we've got 4 plus, if we expand the brackets, what do we get? Do you remember? So 3 lots of n minus 1, what do we end up with? So 3 times n is 3n. 3 times minus 1 is 3.
Negative.
Negative 3, good. Okay. Can we simplify that at all? So I'm going to write my 3n, that bit's there, but what about 4 and minus 3?
Just n.
There's no n's there.
1.
4 minus 3 is
1.
negative 1, positive 1,
Bottom.
positive 1, isn't it? Because I would write, I put the 3n first, and then it would be plus 4 minus 3, okay? And plus 4 minus 3 is plus 1. Is that what we had before?
Yes.
It is. So that formula works. Let's have a look. Example 1. Right? Just from the textbook, we've just done an example, but this is a good one. You'll notice this time though, we don't have the whole sequence. Can you read that? So an arithmetic sequence has the first term 7 and the common difference of -3. What does that mean, by the way? If the common difference is -3, down by 3. Good. Now we have got a choice. We could, if we wanted to, just write, oh, if the first term is 7 and it goes down by 3, what are the next odd terms? It would be 4, 1, -2, -5, and so on. Could you give me the general rule for that? UN equals -3n, but -3 times 1 is equal to -3, and I need 7, so add, so from -3 up to 7, 10, alright? So it would be -3n plus 10. That's one way to do it. The other way is what they're hoping we'll do in this exercise at the moment, is to actually say, oh, okay, so just using the 7 and the -3, right? 7 is the, well, that's U1, the first term, so that is the A value, and the common difference is the D value, so A equals 7, D equals negative. So if I said that A equals 7, D equals -3, the formula is, anyone remember? U1 plus n minus 1 times D. Okay? So what do I put where? Sorry, that shouldn't be an A1, that should be an A, shouldn't it? So what do I put instead of the A? 7. 7 plus n minus 1 times, which is, now I put it in brackets just because it's a negative number and I want it to multiply and not looking like a subtraction, okay? So, what do we do? I'm just going to rewrite it up here, so that's UN. UN equals 7 plus, I'm going to put it the other way around there, -3 times n minus 1. We've got to expand these brackets. So it becomes 7 plus, what's -3 times n? So -3n. -3 times -1. Positive 3. Good. So then I'm going to write the -3n first. So -3n, and it's going to be plus 7 plus 3. So what does that become? -3n plus 10. We got the same thing, yeah? Again, which way is easier? The first way. But we're learning as good. Okay, have you written? You want to come back? Have a look at not example 2 because it's geometric. That's geometric as well. That's geometric. So we need to look at geometric next. All right. But I think, did I give you a? We'll go back to geometric. I didn't give you anything else. All right. Let's. We've only got a few minutes. In your book for me, right? In your maths book, okay. So we'll write another example for us to do just quickly, and you're going to do this for homework, right? I'll give one question or two for you to do by tomorrow. So write this down. An arithmetic sequence as a first term of -4 and a common difference of 6. Write out the explicit formula and use it to find U101. Pause just in case you watch it. You don't need to do the multiply out brackets step. You don't have to do that. Does that make sense what I've just said there? So, for instance, here look, where we had it set up with the formula, just put the numbers in, and then I said, is that the same as we got the other way? I had to expand the brackets and stuff. You don't have to do that. You could leave it as something plus n minus 1 times d, and just use it to figure that out. Right. Don't need to put that on manage back, because it's one question and you're doing it for tomorrow. That will be a consistent approach. What do you need to do though? Well, what do you need to do on top of this assembly? The e-assessment. Get yourself sorted, get your laptop sorted, access it, look at the information, see what it looks like, check out the calculator on it, all of that sort of stuff. Make sure that it's not going to be a surprise and you have it coming up.